Hello. If only I had a dime for every time someone said, "Oh, I'm going to use RTK on this project, and therefore I'm going to get really good measurements from the drone data." Unfortunately, that's not quite true. There isn't just the RTK that matters, and in fact, there is a bigger aspect of drone operations which can have a big influence on whether or not you get good measurements. We'll have a look in this video. Hey everyone, I'm Varun from Hammer Missions, and if you've seen our channel, you'll know that we cover lots and lots of things about using drones, drone data, AI, building inspections, solar farm inspections, all sorts of different things. And in this particular video, what I want to do is I want to try and break down the different concepts of drone data accuracy. Now, there's a lot of confusion on this particular topic, and one of the things that I commonly hear is people conflating absolute accuracy with relative accuracy and using a method that actually improves absolute accuracy and thinking that that's going to help with relative accuracy. Now, I don't want this video to become a whole video on jargon, and I want to try and explain these concepts as if I was explaining to a beginner, and also try to have something in there so that if you are an advanced drone professional, you're also able to take away something from this video. So without further ado, let's get into it. Okay, so what we're going to do today is actually we're going to start with something called relative accuracy or internal accuracy. Now, the big use case for relative accuracy or internal accuracy is actually measurements. So if you want your measurements to be accurate, one of the things you've got to pay attention to is how good is your 2D map or 3D model that you've generated from the drone data. And when I say how good, really what I mean is how good is that map or model in terms of its resolution. Resolution for a drone data essentially implies how much of the real world is the data showing. So essentially, if you think about the resolution and quality of the data, there is this parameter that you have to keep in mind, which is GSD or ground sampling distance. And what that means is that as you're flying your drone to capture a certain area, whether it's a piece of land, whether it's a building wall, whether it's a roof, you've got to think about how much of that surface area are you capturing in every pixel of the drone's camera. Now, why is this even important, and why do people keep talking about GSD? In fact, we made a whole video on GSD and a number of videos, and if you're wondering why have we made those videos and why is GSD so important, I want to try and break it down for you in this video. So think about what happens when a 2D map or a 3D model is created. Basically, what you're trying to do is you're trying to capture the real world and you're trying to represent it as a 2D map or a 3D model. And if you think about a photograph, what is a photograph? A photograph is basically a number of pixels that are trying to represent the real world in some shape or form. The closer you are to a certain object, the more detail you're going to have, and the further away from you are from an object, the less detail you're going to have. Now that's quite intuitive. So if we are, for example, flying 30 feet from a particular building or 10 meters, you're going to have a certain amount of centimeters, certain amount of inches in every pixel of the drone's camera. And if you move the drone closer to the surface, you're going to have even less distance in every pixel of the drone's camera. We're showing this visually and hopefully that makes sense to you. And equally, if we move the drone really far, so if we get ourselves 200 feet from the land or 200 feet from the building, we're going to see more of the surface or the distance in every pixel of the drone's camera. Now, why is this important and why do we care when it comes to measurements? So when we are measuring something on a 2D map or a 3D model, what we're trying to do is we're trying to say, how far is one point from another point? Okay, so think about yourself as being someone who is actually in this map or model, right? And imagine you can see all these points around you. You're trying to say, well, what is the distance between this point and that point? And if the resolution of the data that you've captured is such that those 2 points are actually captured at a resolution of a meter, basically you cannot have centimeter level accurate measurements. And that's quite intuitive because those 2 points are within the same pixel almost, so to speak, in the drone's data. And so you cannot expect to get centimeter level accurate measurements when those 2 points are essentially the same point when it comes to the capture. So this is why the GSD, or the ground sampling distance, really matters. And I really want to hammer home this point in this video. Essentially, getting close to the subject is what allows you to get detail in your data sets and allows those 2 points, whether they're 2D points or 3D points, to be actually spaced out in a way or captured in such a resolution that you can actually measure them to their true distance. Now, there is a trade-off here. You obviously can't capture something so close that you're basically spending days and weeks capturing everything. You're ultimately modeling reality. You can't really replicate reality in the same way. And so there is an approximation. There's going to be an error. And you need to find the right balance between how close you need to be and what kind of accuracy you need for your measurements. And therefore, the thing I want to basically have you take away from this video, that in measurements, how close or far you are to the subject is going to have a bigger influence than some of these other methods that we constantly talk about, things like RTK, GCP, and PPK, which we'll come to later in the video. So proximity to the subject, proximity to the object is really important. And it's important because that it governs GSD, and GSD is what governs the relative accuracy. And for a rule of thumb, your relative accuracy will be somewhere between 2 to 3 times your GSD. So whatever you are capturing the data at in terms of the GSD, you have to multiply it by 2 or 3 to be able to think about the relative accuracy you can expect. So for example, if you are capturing the data at 1 centimeter per pixel, so essentially about half an inch per pixel, basically what you're looking at is accuracy, which is going to be 2 to 3 centimeters in terms of relative accuracy, in terms of the measurements being accurate. Now, the other thing that can influence GSD, and I don't want to go into too much detail here, but I want to just make you aware of this, is that GSD is a function of the distance to the subject, so how close or far you are from a particular object, but also it is a function of the camera that is used. And that's because different cameras have different focal lengths, they have different camera properties, and depending on the camera that is used, you might actually be able to capture more surface area or less surface area per pixel of the drone's camera, and that can have a big impact on GSD. So we've done some calculations and made a whole video on this where you can actually use a better camera and you can afford to be slightly further away from the subject and still capture really, really good GSD to be able to get measurements that are highly accurate or accurate to the specific problem you're trying to solve in your project. So that was all about relative accuracy. To recap, it's all about how good is the resolution of the data. By resolution, we mean how close are 2 or 3 of these 3D points that we're trying to measure, and how confident are we that internally they are represented in the right place and that we can easily measure the distance between them both in 2D and in 3D. And a lot of it really depends on how close can you get to the subject, and also depends on the camera that is used. So next time someone says, hey, I want to get really accurate measurements, before jumping to RTK, PPK, let's think about GSD. Let's think about how close can we get to our subject, and let's think about how far do we need to be able to be efficient and to be able to create 3D models and 2D maps, and really focus in on GSD as opposed to RTK, PPK, and GCP. So rather than just being parrots in the industry and echoing what we've heard from someone, we can try to truly understand why these concepts matter. Now, I don't want to pick on GCPs, RTK, and PPK too much because they are really important methods as well. And that brings us to absolute accuracy. So when it comes to drone data, you might be looking to capture drone data for many purposes. We talked about relative accuracy and we talked about measurements, and maybe that's your primary application. Maybe you want to understand how big is that roof? How many windows do we have on this particular building? Or what's the total area of the solar farm? Whatever the application might be. But now we're looking at absolute accuracy. And absolute accuracy is basically saying, well, you've captured this drone map and you've captured this drone 3D model, how accurate is it with respect to the real world? And what I mean by that is, if you were to take this 2D map and 3D model that you've created from drones, and if you had to position it in the real world, is it in the correct place? If we sent surveyors out there to capture data with their own methods of total stations and LiDAR and whatnot, would they come up with the same 2D map and 3D model in terms of the positioning? And can we sort of assume a certain tolerance, certain error rate with respect to how close or far that 2D map or 3D model is? And so absolute accuracy is got to do with the positioning in the real world. Relative accuracy has got to do with measurements within the points relative to each other in the 2D map or 3D model. So that's really important to bear in mind. Now, when it comes to absolute accuracy, you have to think about, okay, well, why is a drone map or a drone 3D model not accurate inherently? And the answer to that is essentially GPS error. So most drones, when they're flown to capture data, they can observe a GPS error of up to a meter. So that is actually the root cause behind when you capture data using drones, why it's not precise enough in the first place. When I say precise enough, what I mean here is, does it align with the real world? So it doesn't align with the real world because you've got GPS error, and the source of that GPS error is basically just GPS systems. And so you have to think about, the way you think about this is, when the drone captures data, of course you see it based on its GPS position, but you have to kind of think about the numbers that you're getting back from the drone with respect to its position. They're actually accurate to 1 meter. So there's actually a bubble around the drone, which is where the drone actually is in terms of its real position, but that's not where it reports itself to be. That's kind of how you have to think about it. The drone almost lies about its position by a meter, and that's a 3D bubble around the drone you have to imagine. Now, I'm just using a meter as a proxy to say it could be 2 meters, it could be half a meter. It really depends on the conditions, and it can also vary based on the accuracy in terms of X and Y, and the accuracy in terms of the vertical, the Z, because one of the values might actually be coming from barometer versus GPS. So a lot of different variables are at play here. But that's the core reason why you don't have absolute accuracy straight out of the box with drones. So because you don't have absolute accuracy, which is that the drone map or model won't align with the real world, you've got to find some supplementary methods. You've got to help out the drone. You've got to give it, a helpful prod in the right direction to sort of help create a 2D map or 3D model that is aligned with the real world and positioned correctly. And to be able to do that, we've got three main methods. We've got GCPs, ground control points. We've got RTK, real-time kinematics, and we've got PPK, post-processed kinematics. Now, this video, we won't have the time to go into the details of all those three. We actually have a really interesting discussion between myself and one of my colleagues that you can go watch as a background to this video. But just to give you a brief outline, GCPs are a method where you're essentially laying markers on the ground and you're spacing them out. And the whole idea here is that you measure the location of these GCPs using a different GPS system, typically a base station. And what you do is you record the position of these markers, and you use those known coordinates to correct the drone data when you process your data. So that's essentially a way for us to tell the drone data processing, hey, my drone I know is actually out by a meter when it comes to capturing the data, but here are some known coordinates that I captured with a base station where I'm quite confident about their positions, and therefore you can take these as an extra input and give me a more accurate drone map or model. And by accurate, I mean positioning in the real world. The second method is actually real-time kinematics. So this method is actually more efficient than GCPs in some ways, but also has its own risks. So this method basically means you use a drone that is RTK equipped. And what that means is that you can essentially use a base station on the ground, or you can use a base station that is positioned somewhere in the world and you can access it over the internet. And that base station satellite systems and the drone essentially help triangulate the drone's real position. And so basically, real time kinematics, as the name implies, corrects the drone position in real time as the drone flies. And so this can be really helpful because, hey, you don't have to lay out all those markers anymore, which is great. But at the same time, you've got to make sure that you've got the right equipment. So you need to have a drone that is RTK capable. You also need to have either a base station or licensed to a network RTK connection. And a lot of this depends on whether you can have the base station correctly configured on site, or do you have internet connection on the site to be able to get those real-time corrections. So this is essentially a method that is also very commonly used these days, and you can definitely use it to be able to correct the position of the drone and essentially make it closer to the real position so that when you process your data, you've already got the right GPS values in there and you're able to get a much more refined results and much more absolutely accurate results when it comes to drone mapping. So that's basically the RTK side of things. And then you've also got PPK, which is basically post-processed kinematics. And so this is a method similar to RTK. We're not going to go into too much detail, but the idea here is that instead of corrections being applied in real time, you have all of the different systems that I talked about in real-time kinematics that record their own position during flight, and a lot of that is corrected in the post. And the advantage of that is that you can actually do this whether or not you have signal failure on site, because essentially each system is independently logging its GPS positions, and you're able to then correct all of that in the office or in an environment where you have less likely chances of failure. So post-process kinematics basically follows the same principle as real-time kinematics, but as opposed to it being real-time, it's done in the post and typically requires specialized software to actually correct all of this in the post before you can process your 2D map and 3D model. Now, why would you need absolute accuracy? Let's say you employ one of these three methods and you're able to get absolute accuracy. So the reason why you might need absolute accuracy is all dependent on what is the use case that you're using your drone for. So typically, if you're in an active construction environment and you're trying to produce drone maps and models that need to align, let's say, with the drawings of the sites, then you probably care about absolute accuracy and you care about whether or not, your drone map, your reality mapping is actually aligning with the plan. And if you're trying to go into a design versus build application where you're trying to understand is everything being built to the right spec, you need to have that level of accuracy. And maybe you need to do that on an ongoing basis if you're doing a construction monitoring job. It all really depends on what is the application. But if you're doing something like an inspection of a structure and you're trying to understand what is the condition, maybe you don't need absolute accuracy because ultimately maybe you really care about measurements. And as I talked about earlier in the video, relative accuracy or internal accuracy already gives you that. And what really matters for that is whether or not you have the right GSD. That will have a much bigger influence on your measurements as opposed to things like GCP, RTK, and PPK, which again are really important, but more important maybe from a construction point of view or maybe a demolition point of view, or basically any point of view where you're trying to ensure that your drone map or model aligns with the real world. So to sum up, there are more than one type of accuracy in drone data. One of them is called relative accuracy, and the other one is called absolute accuracy. Relative accuracy has a bigger influence on things like measurements, and measurements are typically required for an application where you're trying to understand maybe the dimensions of a certain object, but you don't really care whether it's correctly positioned with the real world. Absolute accuracy is basically a type of accuracy where you're trying to make sure that your drone map or 3D model is well aligned with the real world. And to do this, you need to employ three of the methods that I talked in this video. And those methods essentially correct the drone's GPS error that leads to this accuracy error and basically give you a much more accurate drone map. Both have their own independent use cases, and there's no reason why you might not want to combine them. So if you really wanted to get really good measurements and you really wanted to make sure your maps and models are also in the right place in the real world, you can absolutely combine both methods, get the right GSD, get the right GCPs or RTK or PPK, put everything together, and you have an amazing, absolutely accurate and relatively accurate drone map. But there's a big but. You have to think about what is really needed for the job. Ultimately, we don't want to do things just because we can. I think a lot of these jobs, a lot of these projects require investments. They require investments in hardware, investments in operations, investments in time on site. And doing everything for every single project may not be the best way to look at it. Sometimes prioritizing efficiency and just choosing the right type of accuracy is the best way forward, and also means that we can actually deliver the right outcomes as opposed to get obsessed by the right jargon or the right word or the right sort of thing used on the project. So I think that that's the core message I want to give out in this particular video. And hopefully this video is watched enough that one day I don't hear GCPs used in the context of measurement accuracy and GSD basically not mentioned at all. So that's my hope for this video. Let me know what you think, and if you have any comments on accuracy and what you sort of seen with the drone data you've captured, we'd love to hear your stories. If there is a different method you've come across where you're able to actually get the best of both worlds, or there's an efficiency driver that could benefit people watching this video, do comment in the comment section below. We are Hammer Missions. If you like this video, give us a subscribe. We'd love to see you in some of our future videos. Thanks so much for watching. We'll see you next time.